Now B is where it gets a little more complicated. So we have to consider all the possible ways this could occur. So I'm going to kind of do this out here to the side for you. And whenever we go do the next ones, we don't have to be so precise with it. So, excuse me. Okay. So we can have one or more of the children will have the disease. So that means one can have the disease, or two can have the disease, or three can have the disease. So however we want to do this, that's fine. I'm going to show you another way when I get to the end of it, and you're going to be mad at me, but you just suck it up. It'll be okay. So let's start with just saying that one will have the disease. Now, there's not just one way that could occur, because these are all three different births. So if we have one with the disease, so here's all my abilities, one with. Okay. So my first kid can have it, and then my other two be normal. That is a different scenario than my second kid having it and my other two being normal. And different than my third kid having it and my first and second being normal. So these are all three separate events. Now the probability of each event is still the same, but there's different ways it can occur. So 64th. So the quick way to do that right there is to say the probability of one getting it. So here's the quick way. We can say one normal and two. Oops, sorry, I didn't mean to close that parenthesis right there. So that's 9/64. But there are three different ways that can happen. So it's 3 over 1, so 9 times 3 is 27/64. Now, this event here could happen, or this could happen, or this could happen. And so that would be or conditions, so that would mean we would add those three together, which would give me a total of 27/64. So I did it a little bit shorter down here, this 27/64 at the bottom. And the top was just to explain how I got that number. So down here is the quicker version of it. So that's one way. It's because it says one or more. So we have to consider anything else that can happen. So for two with the disease, the first one could have it, and the second one could have it, and then the third one be normal. Or this could happen, this second one could be normal, or the first one could be normal. So there's three different ways this can happen also. So that's 3/64. I got three ways that can happen. That's 9/64. So here, my first way, I'd have 27/64. The second way, I'd have 9/64. Or I could have all three with the disease, and that one's the easy one, because there's only one way that can happen. 1/4 times 1/4 times 1/4, which gives you 1/64. So if one has the disease, the probability is 27/64. If two have the disease, that's a width, yeah, then I got 9/64. And if three have the disease, then I have 1/64. So this can happen, or this can happen, or this can happen. And so that gives me 37/64. Now, to make that even more simple, this is where you're going to be mad at me. The only other thing that we didn't look at there is showing that no children have the disease, which we did in part A, right? So that was 3/4 times 3/4 times 3/4. Well, the opposite of that is that at least one has the disease. So if we were to take the probability of 1 and subtract it from A, which was 27/64, so that's 64/64 minus 27/64. That actually gives us 37/64. So this is called the complement method of doing it. You can do it that way if you understand it that way. This way up here is a little bit more spelled out and shows you why all those events occur. But if you understand this complement thing, that's great too. If you're going to take the statistics class, or you have taken it, this is something that they usually teach you to do. All right, so that is part B.